So, how do we use these climatological data? Litigation, I've been involved just last year helping lawyers in lawsuits on things. Consulting and engineering, designing systems. Communications, if you got cable or satellite TV, sometimes the weather's bad, you don't get your TV. Agriculture, we've got a drought in Georgia that's hurting our crop output. Medical fields, public utilities, when it's hot and dry, they have to burn more coal for air conditioning. Insurance industry, all these things are uses for climatology data in addition to scientific research. Now, yeah?
How can climatological data affect the medical?
Well, for example, y'all, have you got your flu shot yet? Okay, I'm gonna get mine Tuesday. When you have cold, wet weather, there's more flu. Okay, that's just one way. When you have hot, polluted spells in the summer, people who are older and maybe they smoke cigarettes and they've got lung disease, they're the first ones that die when it gets hot and air pollution goes up. So don't ever smoke. I give a lecture on air pollution to my students, talking about all the bad things air pollution does, and I said, if you smoke, don't worry about it, because the smoke in your lungs is far worse than the air pollution. So I mean, you're just killing yourself, so don't even worry about the air pollution. But those are all ways that it can be done. Winds carry parasites and bacteria, so there's many, many things that it can do for you. Well, I want to do a little exercise with you here, and this is called the hockey stick. Why? Because it's kind of shaped like a hockey stick, and what we have is a bunch of different kinds of measurements of reconstruction for the last 1,000 years. Now, back about 1,000 years ago, in the Middle Ages, when there were knights in shining armor and all that kind of stuff, it was relatively warm. You may have read about the Vikings, Leif Erikson, and those who went to Greenland. Actually, it was his father, Eric the Red. They colonized. They actually farmed in Greenland. You can't farm in Greenland now because it's ice. Greenland was one of the first real estate hoaxes. In order to get people to move there from Iceland, they called it Greenland, because who wants to go live in a place called Iceland? So they got people to go to Greenland, and then Greenland got covered with ice, and Iceland got green on it. But that's beside. It was warmer then. And then we had this period from about 1500 till about 1850 that we call the Little Ice Age. So, what caused these? Well, that's an excellent question. There's some evidence that changes in ocean currents. The Gulf Stream had something to do with it. There's some evidence that Little Ice Age, there was a lot of volcanic activity going on. Volcanic eruptions cool the planet. So, what's our little exercise is, let's sit here and do some brainstorming and see, how do you think we got these data? Where did they come from? So, yes?
All of the technologies that we're setting up everywhere.
Okay, well that's where we get this. That's where we get that. But we didn't set any technology up back when Robin Hood was running around Sherwood Forest, so yeah.
By digging through the ice and catching
Ice core stuff, yeah. Okay, what else?
the tree ring.
I'm sorry?
The tree ring.
Tree rings, yeah. Yeah, what else? How else would we go back and do that? Tree rings, yeah.
Glacier.
Glaciers, yeah, digging through the ice, yeah. You?
Coral.
Coral, yeah, we can go back and see what the coral reefs look like back then, certainly, yeah.
You can see in the sedimentary rock.
We can go back. Now, let me tell you, you gotta be a little careful with sedimentary rock. It takes millions of years for sedimentary rock to form. So, if we wanted to go back and see what it was like 100 million years ago, that would help. But we haven't made a lot of sedimentary rock in the last 1,000 years. We could go look in the mud on the bottom of the ocean, but that's a very, very slow process. So that's less likely to be useful here. That's where you want to go way back. What else? Well, let me say something to you. do you think we might have to be a little bit careful about comparing these temperatures to those temperatures? Because we measure them different ways. Again, if I wanted to count the people in a room, I could count noses, one person per nose, or I could count toes, count 10 toes per person. But what if somebody had an accident and was missing a toe? Every now and then some people are born with 6 toes on one foot. So in comparing those, I could get different numbers, right? Or how about if I just assumed that half of you were going to go get a Coke as soon as we're done, and I went and counted the number of Cokes that went out of that machine out there. And said, okay, I'm just going to double that number, and that's how many. So that's why you have to be careful. You have to be careful. Just like I said, comparing temperatures that were made in 1850 in a place like New York City or Atlanta. What did Atlanta look like in 1850? There wasn't much here, right? It was actually kind of a small town.
It was like a train station.
Yeah, there was a couple train stations and a few houses. And then in 1864, Sherman burned it all down and they started all over again. But even 50 years ago, Atlanta was pretty small. It was all inside the perimeter. Now Atlanta goes from Macon to Chattanooga. You know, so it's much bigger. So you got to be careful comparing temperatures, even though they might have both been made with a thermometer, is that it's much different now than it was then. So you got to be careful, and there's no really way to know how to correct for it. You can guess at it, but you also just have to keep in mind the uncertainty, the amount of uncertainty that you have in there. So do you have any questions? Yes, ma'am.
When you look at a line average like that, and you know there's going to be outliers on the low and outliers on the high, this is just 1,000 years. From the paleoclimatology, do we have this same spectrum but on a broader
Oh,
range?
yeah. If you go back, hundreds of millions of years and things like that. As I said, there's been periods, we believe the whole Earth was covered with ice. And it has to do with the so-called Wilson cycle of plate tectonics. Have you all heard of Pangaea, the supercontinent? We're about halfway between Pangaea and Pangaea Ultima right now. Well, it's believed that when we make the supercontinents that it triggers major ice glaciations thick enough so that the whole planet is covered with ice. There's no open ocean. And then a volcano's burning through, put carbon dioxide in until it melts again. So during much of the planet, we've been much colder than we are now, especially over the last millions of years.
So except for those really extremes, where is 2004 on that?
Well, this actually, it's actually lower than some previous extremes in the more recent period, and it's substantially higher than these major glaciations. But there's some evidence that during the periods after the snowball Earth melts, we can be 10 to 15, actually carbon dioxide levels sometimes 50 times what they are now. So are we going to destroy the planet? We're not going to destroy the planet. We might make it so that it's not very nice for us. We might make it so that lots of people die because they can't get enough to eat. In 1815, there was a major volcanic eruption in Indonesia. And the next year, 1816, in Europe was called the year without a summer. It was so cold from the volcanic ash in the stratosphere reflecting sunlight that there were crop failures and there were food riots in France. So these things can have a big impact. And of course, we can get hit by another giant meteor like the one that we believe took out the dinosaurs 50 million years ago. At first it's going to get real hot and then it's going to get real cold again. So there have been some real extreme events. But right now we've got kind of a sensitive planet because of all the people on it. 6-7 billion now. And we've got places like India and China that have huge populations and are undergoing massive economic growth. I think China brings out a new coal-fired power plant every 3 days.